Hi, AP Calculus students. Welcome to 7.1, A, B, and C, the worked out problems video that we didn't get to in class. Let's look at problem number 23. They are asking for, they give you the function f of x equals x squared minus 4x, and g of x equals 0. Right, that is when you input an x, it outputs a y, y equals 0 is the x-axis. And they're looking for us to sketch the region and find the area. So what we need to know then is where this parabola actually hits the x-axis, right? Where it bounds itself, the region bounds itself to a lower x and an upper x. So let's go ahead and set f of x equal to 0, and let's factor it. And that would be x equals 0 and x equals 4 is where this parabola hits the x-axis. So let's go ahead and do a sketch of that. 1, 2, 3, 4, right? And of course, when I put a 0 in, I get a 0 out. Of course, when I put in a 4, I get a 0 out. What do we get when we put in a 1? Sorry, a 2. Oh, sorry about that. When I put in a 0, I get a 0 out. There we go. When I put in a 4, I also get a 0 out. When I put in a 1, I get a -3 out. Not that you need these, just showing you, what the parabola looks like. When I put in a 2, you get a -4 out. When you put in a 3, that's 9 minus 12, you get a -3 out there, right? And we knew this was a parabola that goes upward. So we're trying to find the area of this region right here. So let's take a look. We have an upper function, which is 0 minus the lower function. Right, so our x's are going from 0 to 4, dx, and let's see, we have 0 minus the function x squared minus 4x. Again, upper minus lower. So this is a -x squared plus 4x dx. Let's go ahead and integrate. That's a -x squared over 2. Sorry, late at night, add 1 to the exponent, divide by the new exponent. That's a -x cubed over 3. I'm going to slow down, take it easy. What time is it? I know it's only 10 after 8, but it's been a long day. Oh, plus add 1 to the exponent, divide by the new exponent here. And we get 2x squared. Let's evaluate that from 0 to 4. Again, and notice that I'll do my f of b. I won't have to do my f of a because it's 0. I get a 0 here and here. So let's see, that's a -64 thirds. Plus when I put a 4 in, that's a 32, right? I am going to switch that to in terms of thirds, right? So that would be 96. Right, so -64 thirds plus 96 thirds is, let's see, 32 thirds. And that, in fact, is the area. And of course, we had to get a positive area out whenever we do upper minus lower. Okay, next we're going to try number 25. Okay, number 25. Same thing. They give us 2 functions. They don't give us the intersection points. They ask for the sketch of the region and to find the area between. So on number 25, we have f of x equals x squared plus 2x, and g of x equals x plus 2. Now, in general, because I know this is a parabola that goes upward, and this is a line, I do know that the line is going to be above the parabola. And let's go ahead and do it and see that that happens. First of all, I need to know, so apparently these 2 functions bind themselves. between two x's. Let's find out what those are. So x plus 2 equals x squared plus 2x. I will get everything to the right. So that would be x squared plus x minus 2. Let me make sure I did that right. I'm going to subtract an x here, subtract a 2. Excellent. So that would be x plus 2, x minus 1. Excellent. And so that would be an x of negative 2 to an x of 1. Okay, let's go ahead and sketch that form. Let's go ahead and graph the line first, right? The line is at negative 2, right? It's at 0. At negative 1, it's at 1. Obviously at 0, it's at 2. And at 1, it's at 3. So here is the line that we have. Let's go ahead and sketch the parabola. When we put it in negative 2, we get a 0 out. Of course, we said that they intersect there. When I put in a negative 1, yes, a negative 1, that will be 1 minus 2, that's a negative 1. When I put in a 0, I will get a 0 out. When I put in a 1, I will have a 3, and we said that was going to happen. Again, we also said the line would be above the parabola because the parabola is concave up, so that made sense. So we have an upper function minus a lower, right? And so that would be negative 2 to 1. And let's see, that would be x plus 2 minus x squared plus 2x dx. Negative 2 to 1, x plus 2 minus x squared minus 2x. Negative 2 to 1, this would be a negative x squared and minus x plus 2 dx. All right, just distributing my negatives, just going to check real quick. Did I do okay? I think I did. Okay, let's integrate. Add 1 to the exponent, divide by the new exponent. And we will do our f of b minus our f of a. Okay, f of b, I'm going to put a 1 in. That would be a negative 1/3 minus 1/2 plus 2 minus my f of a. Going to be a little careful here when I put a negative 2 in. When I put a negative 2 in, this is a negative 8/3. Right now it's a positive 8/3. When I put a negative 2 in here, this is going to be a 2 minus 2 and minus 4. Okay, let's gather our like terms here. I'm going to distribute this negative. Okay, and it would appear I have a negative 1/3 and a negative 8/3 is a negative 9/3, which is a negative 3. I'm just going to bring along the negative 1/2. And I have plus 2 plus 4 is plus 8. So it would appear that I have 5 minus 1/2 would be 4.5. There we go. And there is problem number 25. Let's look at problem number 28. Same section. Y equals 1 over x squared. Right? Y equals 0. And x equals 1. And x equals 5. So that's cool. They already gave us the upper and lower boundaries. Let's go ahead and graph from 1 to 5. And let me check on 28. Yep, that is 1 over x squared. So 1, 2, 3, 4, 5. Notice when I put in a 1, I'm going to get a 1 out. And when I put in a 5, right, I'm going to get a 1/25 out. So I'm like way up here at 1, right? So when I put a 1 into the function, I get a 1 out. When I put in a 5, I get a 1/25. It is going to make this nice curve because it is rational. And we are trying to find this area here. Notice I have upper, right, minus lower in terms of x, and I'm going to collect that across x's from 1 to 5. So let's take a look from 1 to 5. That would be 1 over x squared. If it's okay with you, I'm going to write that as x to the negative 2 dx, right? So upper minus lower, my lower function happens to be 0. I'm going to add 1 to the exponent and divide by the new exponent. And I get negative 1 over x from 1 to 5. Let's do our f of b. That is a negative 1/5 minus our f of a is a negative 1. We make that 1 positive and we get 1 minus 1/5 is 4/5. There we go. That's problem number 28. Okay, on problem number 21, same question. We have y equals 1/2 x cubed plus 2 and y equals x plus 1. And they give us x's in between 0 and 2. So that's kind of nice that they gave us the boundaries here. So let's see if we can draw a picture of that. Let's see, 8, 4, 6, just trying to get an idea of what I need my axes to be. I think we're all positive. Let's go ahead and do this. So 0, 1, 2, and 3. And I'll go 1, 2, 3, 4, 5, 6, 7, 8. Let's see if that does it. Let's go ahead and between 0 and 2, let's draw the line first. You know what? Notice I always do the easiest first. So when I put in a 0, I get a 1. When I put in a 1, I get a 2. When I put in a 2, I get a 3. There we go. There's the line. Let's look at this cubic equation. When I put in a 0, I get a 2. There we go. When I put in a 1, I get 2.5. And when I put in a 2, let's see, 2 cubed, that's 8. A fourth of that, a half of that is 4 plus 2 is 6. There we go. So that's 1, 2, 3, 4, 5, 6. So way up here. Okay, that kind of takes this shape. There we go. So here's our area. Notice the upper function is the cubic function. We are going to integrate from 0 to 2. This cubic function minus this line in terms of x, right? Going across the x axis, right? So we have 0 to 2, 1/2 x cubed plus 2, right? Minus x minus 1. Right? And so just a very small change here, 1/2 x cubed minus x. I'm just going to gather my like terms. Plus 2 minus 1 is a plus 1 dx. Let's go ahead and integrate. I'm going to add 1 to the exponent and divide by the new exponent. That is 1/6 x cubed minus x squared over 2 plus x. We're going to evaluate that from 0 to 2. Notice I'll just have to do my f of b because my f of a is 0. So let's see. When I put a 2 in here, this is 8/6. When I put a 2 in here, this is minus 2 plus 2, right? And I get 4/3 is this area on number 21. Oh, that's not what they have that the area is. Okay, what did I do? Oh, it must have been, oh, gosh darn. Okay. Oh, let's go on back. Sorry. And I would go ahead and, like restart the video, but I've gotten pretty far. So you may have noticed right here, I didn't add 1. Like I wrote a 2 by mistake. I needed to add 1 to the exponent, and that would be a 4. Sorry about that. Isn't it, again, funny how the calculus is okay, but the little details, again, are not. So let's go back to where we were here, right? So we were correct here. Again, let me do my little bit of math. of, right, kept the first term minus x, and I'm going to add a 1. There we go. Sorry about that. Now, I guess I miswrote that. Let's add 1 to the exponent, divide by the new exponent. That's better. That is x to the 4th over 8 minus x squared over 2 plus x. Let's evaluate that from 0 to 2. So sorry about that. Let's try this again. That would be 16/8, right, which is 2. And then this would be, when I put a 2 in, minus 2 plus 2. And I am left with a 2. And that's what the answer is. So sorry about my mistake on the exponent there. Let's try one last one. Okay, let's go ahead and do number 47, though I do remember doing this in class. But let's take care of it because it's some trig, right? Okay, now they gave us 2 functions, and they give our x's between 0 and 2 pi, right? And so I'll just make my quadrantal interval marks here: pi over 2, pi, 3 pi over 2, and 2 pi. Okay, let's go ahead and do cosine since it's a parent function and we're used to that, right? Cosine is at 1, right? It's 0 radians, it's 0 pi over 2, negative 1 at pi, 3 pi over 2, it's back at 0, and 2 pi, it's back up at 1. So we know what cosine looks like. Let's do 2 minus cosine. When I put a 0 in, cosine is 1, so this is 2 minus 1 is 1. At pi over 2, cosine of pi over 2 is 0. We're now up at 2. At pi, cosine of pi is a negative 1. 2 minus a negative 1 is 2 plus 1. We're now up at 3. 3 pi over 2, cosine is 0. We're back to 2. And at 2 pi, again, that is a 1, and we're back to 0. There we go. So this is the upper function, 2 minus cosine of x, and this is the lower function. Okay, let's go ahead and integrate that from 0 to 2 pi. The upper function is 2 minus cosine, and we are going to subtract the lower function, which is minus cosine. So we have the integration of 2 minus 2 cosine of x dx. Let's go ahead and integrate. That would be 2x minus 2 sine of x. I believe, let me take a look. The derivative here is 2. The derivative here is a negative 2 cosine. And we will evaluate that from 0 to 2 pi. Okay, let's put in 2 pi. When I put f of b, 2 times 2 pi is a 4 pi. Minus sine of 2 pi is 0. Let's do our f of a. We have a 0 and a 0, and we get 4 pi is the area. Have a wonderful day.